In this episode, we're going to take vulnerability work out of the world of random scans and long spreadsheets and turn it into something that feels like a real program with a clear purpose and a clear flow. A vulnerability program is how an organization finds weaknesses, understands which ones matter most, and reduces exposure over time in a steady, repeatable way. Beginners often assume vulnerability management is simply patching, but patching is only one possible response, and it is not always the first or the best response for every situation. The hard part is not finding issues, because modern environments produce findings constantly, but deciding what to do first and proving that the most important exposure is actually shrinking. To do that well, you need three foundations that hold the whole program up: knowing which assets are most critical, classifying what you have in a consistent way, and prioritizing work based on risk and impact rather than noise. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A vulnerability management program, VMP, is a set of routines, responsibilities, and decision rules that help an organization reduce the time it spends exposed to known weaknesses. It includes discovery, validation, triage, remediation planning, verification, and reporting, but the key word is program, meaning it runs continuously and improves over time instead of being a one-time cleanup. When a program is weak, teams do heroic work right after a scary report and then fall back into silence until the next crisis, which is stressful and ineffective. When a program is strong, teams expect a regular flow of findings. They understand what must be addressed first, and they can show leadership that exposure on critical systems is trending down rather than bouncing around. The program is also a coordination system, because security rarely fixes everything alone, and many fixes depend on operations, engineering, and business owners. For beginners, it helps to think of a VMP like a health system for your technology. It does not guarantee nothing bad will ever happen, but it ensures problems are found early, treated appropriately, and tracked until resolved. The first foundation is asset criticality, because vulnerabilities do not exist in a vacuum. They exist on assets, and not all assets matter equally. An asset is anything that provides value and can be affected by security risk, such as an application, a server, a database, a device, or a service that customers depend on. Criticality is a way of describing how important that asset is to the organization's mission, safety, finances, and trust. A beginner misconception is that the most technically severe vulnerability is always the most urgent, but a weakness on a low-impact system can be less urgent than a moderate weakness on a system that supports critical operations. If your program treats all assets as equal, you will end up spending time on the loudest findings rather than the most dangerous exposure. Asset criticality is how you give the program a map of what matters most, so prioritization decisions have a stable anchor. To determine criticality in a practical way, you focus on impact, meaning what happens if the asset is compromised, altered, or unavailable. Impact includes business disruption, customer harm, safety implications, legal obligations, and reputational damage, but you do not need to turn it into a complicated math exercise to make it useful. Instead, the program needs a consistent method for labeling certain assets as high impact because they handle sensitive information, enable critical services, or perform essential functions. The more consistent the labeling, the easier it is for everyone to understand why a particular vulnerability is being treated as urgent. Another beginner misunderstanding is to assume criticality belongs only to security, but criticality must be agreed with business and operational stakeholders because they understand dependencies and real-world consequences. When criticality is set collaboratively, it becomes easier to get action because teams recognize the priority as legitimate rather than arbitrary. Once critical assets are identified, the vulnerability program can focus first on reducing exposure where the organization has the most to lose. The second foundation is classification, which is the practice of grouping and labeling assets and findings so decisions can be made consistently. Classification sounds bureaucratic, but it is really about avoiding confusion when many teams talk about many systems. Asset classification often includes what type of system it is, who owns it, what data it handles, where it sits in the environment, and how it is used. Data classification, in particular, shapes vulnerability priorities because a system that holds sensitive data requires tighter control and faster remediation when exposure appears. A key beginner pitfall is thinking classification is just a label you set once, but classification must be maintained as systems evolve, because an asset that was low impact can become high impact when it begins storing sensitive information or becomes part of a critical workflow. Good classification also reduces blind spots, because it forces the organization to ask, do we actually know what this system is and why it exists? When classification is clear, vulnerability work becomes faster and calmer, because teams can sort and route findings without constantly reinvestigating basic facts. Classification also matters because vulnerability findings themselves need to be interpreted, not merely counted. A vulnerability can be real or false. It can be reachable or not reachable. It can be easy to exploit or hard, and it can have different consequences depending on what the asset does. If a program treats every finding as equally actionable, teams will drown, trust will erode, and people will start ignoring reports. A healthy program classifies findings by factors like severity, exploitability signals, exposure conditions, and the role the asset plays in the organization. This does not require deep exploitation knowledge to begin. It requires a consistent habit of asking, what does this weakness allow? Under what conditions could it be used? And what would it mean for this specific asset? Classification is how you move from raw scanning output to meaningful decisions. And it is also how you communicate clearly to leadership without overloading them with technical detail. When classification is practiced well, it becomes a shared language that reduces friction across teams and keeps the program from becoming noise-driven. The third foundation is prioritization, which is where the program proves it is serious about reducing risk instead of merely cataloging problems. Prioritization is the decision process that determines what gets fixed first, what can wait, and what requires alternative treatment. Beginners often assume prioritization is just sorting by severity score, but severity alone is an incomplete view because it does not account for asset criticality, exposure, or the likelihood that the weakness will actually be used against you. A strong program prioritizes based on risk, meaning it considers impact and likelihood together, using the organization's knowledge of critical assets and real-world exposure conditions. For example, a high-severity issue on an internal test system may be less urgent than a lower-severity issue on a system that is internet-facing and supports a critical service. Prioritization also needs to be predictable because teams will only trust the program if the rules stay stable and make sense across time. When prioritization is disciplined, it turns vulnerability work into a manageable queue rather than an endless fire. To make prioritization work, a program needs a clear intake and triage flow so findings do not pile up in confusion. Intake is how findings enter the program, whether from scanning, assessments, testing, or incident investigation, and triage is the step where findings are validated, scoped, and assigned a priority. At triage time, the program should connect each finding to the asset's owner and to the asset's classification, because without ownership and context, a finding is just an alarm with nowhere to go. A beginner mistake is to treat triage as purely technical, but triage is also organizational because it decides who must act and how urgent that action is. Good triage includes confirming whether the asset is in scope, whether the vulnerability is applicable, and whether the vulnerability is already being addressed through an existing plan. When triage is sloppy, teams get duplicate tasks, false urgency, and rework, which wastes effort and reduces trust. When triage is strong, the program becomes credible because it sends teams a smaller number of clearer tasks that actually matter. Prioritization also depends on understanding exposure windows, which is the amount of time an asset remains vulnerable to a known weakness. Exposure windows matter because a vulnerability that exists for a long time creates more opportunity for misuse than a vulnerability that is quickly contained. A vulnerability program is therefore not only about whether something gets fixed, but how long the organization remains exposed while waiting for the fix. This is why programs often focus on reducing exposure on critical assets first, because those assets create the highest impact if compromised. Beginners sometimes assume a fix is the only option, but in real operations, the program may choose temporary risk reduction steps, such as limiting access, reducing network exposure, or adding monitoring, while a full fix is scheduled safely. These steps are not excuses. They are ways to shrink the exposure window while respecting operational constraints. A mature program tracks exposure time and uses it as a measure of whether prioritization is working, because the ultimate goal is to reduce how long critical weaknesses remain open. A practical vulnerability program also accounts for capacity, because prioritization without capacity becomes frustration. Teams have limited time, change windows, and testing resources, and if the program floods them with high-priority items, people will start treating everything as equally urgent and nothing will truly move. A healthy program defines what urgent means and protects that label so it remains meaningful, reserving urgent treatment for the issues that create the highest risk on the most critical assets. It also supports planning by grouping remediation work logically, such as aligning fixes to maintenance windows and bundling changes that can be tested together safely. This reduces disruption and reduces the chance that a rushed fix causes an outage, which is a security problem in its own right. Capacity awareness also encourages the program to invest in prevention, because reducing recurring weakness patterns is often more effective than endlessly reacting. When a program balances urgency with capacity, it stays sustainable, and sustainable programs are the ones that actually reduce exposure year after year. Asset criticality and classification also shape how the program communicates, because different audiences need different levels of detail. Technical teams need clear information about what is affected, what the expected remediation is, and what timeline applies based on priority. Leadership needs a posture view, meaning whether exposure on critical assets is trending down, where the biggest pockets of risk remain, and what constraints are preventing faster reduction. A beginner misconception is that reporting is separate from the program, but reporting is part of execution because it creates accountability and helps remove barriers. If leaders cannot see that critical exposure is shrinking, they may not support the operational changes needed to improve remediation flow. If teams cannot see how priorities are determined, they may treat the program as arbitrary and resist it. Strong communication connects the classification and prioritization logic to outcomes without turning the program into a flood of numbers. When communication is clear, the program becomes trusted, and trusted programs get results because people follow them instead of working around them. Another crucial element is how the program handles exceptions and compensating actions without letting them become permanent drift. In the real world, some systems cannot be patched quickly because of fragility, vendor constraints, or business timing, and pretending otherwise leads to rushed changes that can break critical services. A mature vulnerability program acknowledges this reality but insists on disciplined risk management when a fix is delayed. That means documenting why the delay exists, assigning an owner, setting a review date, and requiring reasonable compensating controls that reduce exposure in the meantime. It also means revisiting the underlying cause, because repeated inability to remediate often indicates deeper problems like unclear ownership, lack of maintenance windows, or outdated architecture. Beginners sometimes think exceptions are failures of discipline, but exceptions are often signals that the organization's systems or processes are not designed for safe change. The vulnerability program becomes stronger when it uses exceptions as learning inputs that drive long-term improvements rather than as loopholes that quietly increase risk. Over time, the strongest vulnerability programs treat asset criticality, classification, and prioritization as a connected system rather than as separate tasks. Criticality tells you where harm would be greatest, classification tells you what you are dealing with and who owns it, and prioritization tells you what to do first to reduce exposure with the resources you have. When any one of those pieces is missing, the program becomes noisy and reactive, and teams lose confidence. When the pieces are aligned, the program becomes predictable, and predictability is what allows security work to scale in a large, changing environment. You can also improve the program iteratively by refining criticality labels, improving classification accuracy, and adjusting prioritization rules to reflect real-world conditions. The result is not a perfect environment with zero vulnerabilities, because that does not exist, but an environment where the most dangerous exposure is consistently addressed and the organization becomes less surprised over time. That is the purpose of building a vulnerability program, and it is why these foundations matter before you ever argue about specific fixes. When you step back and look at vulnerability management as a program, the main goal is to reduce the organization's risk in a way that is steady, defensible, and sustainable. Asset criticality keeps you focused on what matters most, so the program protects the outcomes the organization depends on. Classification creates shared language and context so findings are understood and routed correctly rather than being treated as random alerts. Prioritization turns constant discovery into action by deciding what needs attention first and by shrinking exposure windows on critical assets. When these foundations are in place, remediation becomes more achievable, reporting becomes more meaningful, and accountability becomes fair because priorities are consistent and transparent. As you continue through the rest of this series, these ideas will keep showing up because almost every security management problem becomes easier when you know what you have, understand what matters most, and can make disciplined choices about where to spend limited time and effort. That is how a vulnerability program becomes a long-term risk reduction engine rather than a periodic scramble.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.